All right, so here is our video to help you to review for your Unit 1 test. As you're watching this video, I suggest you get out paper, pencil, a periodic table, your reference sheet, and your calculator and have them ready to go. So that way you can practice the questions, pause the video often so you can try to get the answers. Remember that we will provide periodic tables and the reference sheet for you. All right, so let's start with some metric conversions. And you do have a lot of this on your reference sheet. So if we were going to convert kilograms to how many kilograms if something weighs 5 grams? So of course my base units are right in here. And so I'm going to go 1, 2, 3. So there we go. And we're also going to convert 254 nanometers to meters and 435 kilometers to millimeters. So, great time to pause the video and see what you get. Of course, I'd already done this one for you, going from grams to kilograms. Hopefully you got that. And of course, I put this in scientific notation. And there we go. Again, I put it in scientific notation. Going from kilometers to millimeters. So 1, 2, 3, 4, 5, 6 jumps. So I took that decimal and moved it 6 times. All right. So don't forget those metric units and what they each mean. All right. So here we go. Here's your next problem. We've got a speed problem here. Great time to pause the video. All right, so hopefully you came up with this. And of course, we've got to round that, to significant figures. So that means it should be rounded to 12.2. Should be where we are for significant figures because our problem has 3 significant figures. All right, here's another one for you, another dimensional analysis problem. All right, so see what you can do. Again, like I said, a great time to pause the video. All right, so there we go. I converted pounds first to grams, and then I converted feet cubed to inches cubed to centimeters cubed. Hopefully you got the same thing. Now, the mistake I've made here, which I'm hoping you don't make on your test, is I did not round for significant figures. So this would be 21.5. That second 5 is would not be there. All right. All righty. Here we go. How about this one? So hopefully you have that conversion. So you know that when I fly my dog to Europe, it's going to be 1.3626 kilograms, and then change that to grams, and then round that off to 3 significant figures, or put it in scientific notation. Here we go. Ounces to pounds. See what you can do. So hopefully you did something like this. Got that many pounds and rounded it to 3 significant figures. All right. How about scientific notation? How are you with scientific notation? Great time to pause the video while you put this number in scientific notation. And there we go. So again, that decimal is right behind the zeros. All right. So don't forget that in most chemical reactions, the electrons are really going to be what we're looking at. They're going to move from various atoms from one atom to another. They're going to be shared. Those electrons can move to those from those lower energy states, their ground state, to a higher energy state, and then settle back down and producing those flashes of light that we've seen. And so just be aware of that. So we've got a little molecule over here. Don't forget that atoms have a nucleus discovered by Rutherford, with the electrons around the nucleus arranged in energy levels and orbitals. Every energy level is divided into an orbital. Don't forget the protons and the neutrons in the nucleus. And don't forget your atomic number is your number of protons in the nucleus, and the mass number is the protons plus the neutrons. And so if you had an isotope of magnesium, with 13 neutrons, we would write its symbol like this. And of course, this magnesium has given away 2 electrons. All right. You should be able to name the groups and columns, so take a moment and see if you can do that. All right, so there are the ones that you need to know. So hopefully you've got 1A, 2A, the transition metals, 7A, and 8A. All right, so what do you think about this one? Hopefully you said ionization energy is going to increase. And again, because the atomic radius is decreasing the protons, you're getting more protons, so more positive charge to pull those electrons in more. All right, see what you can do with this one. So I've written the atoms for you so you can see which atom we're talking about. How many neutrons does it have, and electrons? You could also, of course, do protons. Yes, so hopefully you were thinking 47 neutrons and 33 electrons because it is an arsenic atom. How about this one? So hopefully you were thinking 12 neutrons and 10 electrons because it is a sodium ion, having given one away. How about this one? Oh, and I think I've got a typo here. I can see this should not be arsenic again. This should be iodine. So how many protons and electrons does it have? If it's iodine, hopefully you're thinking 67 neutrons and 53 electrons. All right, one more dimensional analysis. See what you can do. Again, a great time to pause the video. All right, so hopefully you came up with that 0.77 kilograms. All right, here's one more. So how did you do with that? Make sure we round that off to 2 significant figures. You also need to be able to do temperature conversions. So see if you can do that. Again, a great time to pause the video. And so hopefully you got 286 for Kelvin and 55 for Fahrenheit. Great time to either snap a picture of this or copy it so that you can fill it in so we can see what you can do. I would suggest pausing the video and then you can check your work. I'm just going to put up the answers. There they are. I didn't expect them all to come up at once. All right. A couple more questions for you. Potassium, nickel, and bromine. What do they have in common? Yes, they're in the same period. And actually, that would be period number 4. All right. All right. So that's what I have for you for one final practice for your test. Good luck.